Hi, hello there. So up till now, you guys have been finding derivatives of functions by using the definition of derivative with limits. That's what you guys have been doing. It's been very time consuming, and I know that, and it's done for a reason. But it's also been hinted at that there are shortcuts to finding these derivatives. Very helpful, useful, quick shortcuts. And so that's what today's lesson is all about, is some shortcuts for finding derivatives of functions. All right? So I have a list here. Okay, I have several y functions, y equals x squared, y equals x cubed, y equals x to the fourth, y equals x to the 1/2, y equals x to the negative first, y equals 4x squared. And then I also have their corresponding derivative functions. Okay, now I just want you to take a minute, and pause it if you need to, but I want you to take a minute to see if you can come up with the derivative shortcut yourself just from looking at this list right here. Okay, pause it. Take a minute, just look at all of these. Now. Okay. Hopefully you realize that all that's really happening is the power goes out in front of the variable, right? The power, the 2 goes in front of the x, the 3 goes in front of the x, the 4 goes in front of the x, and the exponent decreases by 1. That's called the general power rule for derivatives. The exponent goes out in front, and then you reduce the exponent by 1. And it even works if your exponents are fractions or negatives. For instance, right here, x to the 1/2. If you move 1/2 out in front, you get 1/2. Decrease this by 1, so you get x to the negative 1/2. And then instead of having a negative exponent, put this in the denominator with the 2. And then x to the 1/2 is just square root of x. They are synonymous, they mean the same thing. Even with negatives, move the negative out in front, decrease the negative 1 by 1, you get negative 2. And then put the x to the negative second on bottom, bada bing, bada boom. And even if you already have a number out in front, you take your power, you multiply it by the coefficient, that gives you your new coefficient, and decrease the exponent by 1. So those are your shortcuts right now, okay? Now we've learned them, now you can use them. So it's still important to know the derivative definition. You're definitely going to be asked questions about it, but as we go through our work, we don't want to do that every single time. Here's our shortcut. Okay. So go ahead and jump to the notes now, and we're just going to talk about the basic differentiation rules, the shortcuts that we're going to be working with. We've already addressed it, but let's put it on paper. So the constant rule, okay, what I mentioned over there was the power rule, which we're going to get into, but the constant rule is even simpler than that. If you have a function that equals a constant, so like f of x equals 5, or f of x equals negative 1 million, then think about what f prime is going to be and what f prime stands for. So I don't just want to give the answer right away, but think about this. If you would graph a constant function, okay, doesn't matter what it is. So let's say I graph a horizontal function, so y equals 3, for instance. Think about no matter what point you pick along that line, think about what the slope of that point is. The slope along any horizontal line is 0. So if you take the derivative of a constant function, the derivative is always going to be 0, because the slope at any point on that line, no matter if it's f of x equals 100 trillion, the derivative is 0. So if I have f of x equals 5, then the derivative of 5 is 0. That's your constant rule. Okay, the power rule. All right, if n is a rational number, then the function f of x equals x to the n is differentiable, and the derivative equals, well, now I know we did numeric values all in this list that I had you guys look at, but let's put it in terms of variables. You take the n, you put it out in front, and then you decrease the n by 1. So your new exponent is n minus 1. This is the general power rule for derivatives. Your exponent goes out in front, decreases by 1, the exponent. All right. So if f of x equals x to the 5th, let's think about what the derivative equals. Well, we put the 5 out in front and reduce the exponent by 1. So the derivative of x to the 5th is 5x to the 4th. Now also keep in mind what this does. We have found the derivative for several classes now. The derivative now, if I want to find the slope of any tangent line to this function, this x to the 5th function, I can plug that point into the derivative and it tells me the slope of the tangent line, or instantaneous rate of change, or instantaneous velocity. That's what the derivative does. Always keep in mind what you're finding, even when you learn shortcuts. It's easy to lose track of and lose sight of what we are actually doing. Now, they're not always just going to be set up in this way that you can just move the exponent out in front and subtract it by 1. There is sometimes going to be a manipulation that you have to do before you can use the power rule. You have to manipulate it to get it into this form right here, x to some power, okay? So if h of x equals 1 over x cubed, this is not in that form. I can't just move the 3 out in front and reduce it. We have to get this in terms of x to some power. So think about how we can rewrite this function, and that's going to be part of your task, is to rewrite these functions to then be able to use this shortcut. So 1 over x to the third is really x to the negative third. Now we've put it in the appropriate form. Now we can use the shortcut. So h prime of x then, well, let's move the negative 3 out in front. Reduce negative 3 by 1, so that's negative 4. And then, just to get rid of the negative exponent, we have negative 3 over x to the fourth. There's your derivative function, negative 3 over x to the fourth. Or you could have gone through your entire limit process and gotten there. That's up to you. C. If g of x equals the cube root of x, find g prime of x. Well, this is not in the form we want. We don't want the square roots or the radicals here. So let's rewrite this. Let's think about what the cube root of x means in terms of exponents. Remember, it's always, your exponent is always power over root, power over root, power over root. So I can rewrite this as x to the 1/3. 1 is your power, 3 is your root. That's g of x. Now we have it in the right form, we can find the derivative. So g prime of x equals, let's move the 1/3 out in front. Decrease the 1/3 by 1, you get negative 2/3. Which means then you could just move the x to the negative 2/3 down with the 3. So it's 1 over 3x to the positive 2/3. That is the derivative of the cube root of x. Handy dandy little shortcut. I like it. D. Okay, so D doesn't just say find the derivative. It says find the slope of y equals x to the 1/3 at x equals 8. Anytime a question says find instantaneous rate of change, find the slope of the tangent line, find the instantaneous velocity, you have to find the derivative of the function and then evaluate the derivative at whatever the place is. So we don't know the derivative. Let's find it. Y prime equals, move the 1/3 out in front. That's really what we just found right here, right? We just did this one. So the derivative is 1 over 3x to the 2/3. We want to evaluate the derivative function at x equals 8. So put 8 into the derivative function because we're looking for slope. So y prime of 8 is 1 over 3 times 8 to the 2/3. Now, if this is free response on the AP exam, this answer is acceptable. This is a numeric equivalent answer to what the actual answer is. You don't have to simplify this. However, let's say it's multiple choice and they clean this up. It's important to know how to clean this up and deal with this. Okay, so we have to know how to do 8 to the 2/3 power. We have to deal with 8 to the 2/3. Well, remember, it's power over root. Power over root. So there's two ways you can do this. You can either do 8 squared, get 64, and then find the cube root of that, or do the cube root first, do the cube root of 8, which is 2, and then square that. Either way, you get 4. 8 to the 2/3 is 4. So 1 over 3 times 4 is 1/12. This is the slope of the tangent line to this y function at x equals 8. The slope would be 1/12. E says find the equation of the tangent line. So think about what we need to find equations. You have to know a point and slope. Okay? Point and slope. We already know the derivative of y equals x to the 1/3. That's what we just did in the last two problems. So y prime is 1 over 3x to the 2/3. we need to find the slope at -1. So we have to find y prime of -1. This is going to find the slope at x equals -1. So 1 over 3 times -1 to the 2/3 power. I treat, as much as I can, I try to treat every problem as it's non-calculator. Because 2/3 of your exam is non-calculator. So I try to do as much as I can. Well, let's see. -1 squared is 1. The cube root of 1 is 1. So -1 to the 2/3 is +1. So 1 times 3, so we get 1/3. So the slope at x equals -1 is 1/3. Well, now we need the point. We know the x-coordinate is -1. We need the y-coordinate. So this is where you need to remember or think about, where do I plug this? Do I plug it into the derivative function, or do I plug it in to the actual function? Anytime you're looking for a y value of a function, plug the x value into the function itself, into the original function. So -1 in for x right here. -1 to the 1/3 really means the cube root of -1. Let me say that again. -1 to the 1/3 power is the cube root of -1. So that's -1. So now we have the slope, we have our point. Let's write the equation. Y plus 1 equals the slope times x plus 1. That's the equation of the tangent line to this function at x equals -1. All right. We've talked about this rule already too, but just talk about it again. So if I want to write or find the derivative, remember this notation. If I want to find the derivative and there's some constant in front of the function, for instance, put this in perspective. This list that I had you guys do at the very beginning, there was a constant in front of the x squared function. That's what this is doing. There's some number being multiplied to the function, okay? Then you could take the constant and multiply it by the derivative of the function. You could take the constant and multiply it by the derivative of the function. So here's what that means. If y equals 7/5 x to the 5th, and we want to find y prime, well, we have a constant here, right? 7/5. So what we can do is this. We could take the constant, 7/5, and multiply that by the derivative of x to the 5th. Think about what the derivative of x to the 5th is. Well, that would be 5x to the 4th. And then you can multiply the 7/5 and the 5 together, and you get 7x to the 4th. To simplify that process, really what you're doing is taking that exponent and multiplying it to the coefficient. That's what's happening there. You're multiplying the exponent to the coefficient, reducing your power by 1. B, if y equals 2 over 3x squared, what is dy dx? Just new notation. Think about what dy dx means. This is asking for the derivative of y with respect to x. That's really what this is saying. What is the derivative of y with respect to x, meaning x is your independent variable? It's saying find y prime. So first, look at this. We don't have this set up in the form that we need. We need x to be basically in the numerator. We need to rewrite this. So I can rewrite this as 2/3 x to the -2nd power. You can move that x squared out of the denominator and rewrite it as x to the -2nd. And then we can find dy dx. We could take this power, multiply it to the coefficient, so we get -4/3, and then reduce your power by 1, so x to the -3rd. And then we can move x into the denominator, so we get -4 over 3x cubed. There's your derivative. But again, you have to manipulate the original function first to then be able to use the shortcut. All right, just like when we talked about limits, if you have the limit of a sum, you can add the individual limits together or subtract. So here, if you have the derivative of f of x plus or minus g of x, that is the same as doing f prime of x and then plus or minus g prime of x. all it's saying is if you have multiple terms in a function, you can differentiate every single term individually. That's what it's saying. So f of x equals x squared minus 3x to the negative second. Find f prime of x. So again, all this means is we can just differentiate every single term separately, and that'll be our derivative. So f prime of x equals, well, let's differentiate x squared. So we're going to get 2x to the first, so 2x, minus, this shows up a lot. If you differentiate and it's just x to the first, the x just goes away. So it's just going to be minus 3. Because if you decrease the 1 by 1, you get x to the 0, which is 1. It goes away. And then right here, if we multiply negative 2 and negative 3 together, we're going to get plus 6, x to the negative third. Again, we're multiplying negative 2 and negative 3 together, so positive 6. And then move the x to the denominator. So we have 2x minus 3 plus 6 over x cubed. Now here's the thing. With limits, it worked for, you could split up the addition, subtraction, you could split up the multiplication, like you could find the limit of the top and bottom, you could find, or the two products, or you could find the limit of a fraction. With derivatives, here's the deal. We're going to learn ways that you can find derivatives of fractions and derivatives of products. But you can't, if it's a fraction, just take the derivative of every single term on the top and the bottom. It does not work that way. There is going to be a rule that we learn called the quotient rule. There's going to be a way to find the derivative, but we're not learning that yet. Same as if I had y equals, I'm just going to make up one here, 6x squared times 4x. You can't just take the derivative of each term and then multiply them together. There's going to be something called the product rule, but we're not there yet. So because we're not there yet, think about what we can do to manipulate this expression. When you're dividing by a monomial, by one term, you can take every term in the numerator and divide it by that denominator and split it up into 3 separate terms in this case. I can write this as y equals, well, 2x squared divided by x is 2x. Negative 3x divided by x is negative 3. And then plus 1 over x, which is x to the negative first. So take every term in the numerator and divide it by x. Now we have a function that we can differentiate every single term separately. So with that said, dy dx equals, well, the derivative of 2x is 2. The derivative of a constant is 0. The derivative of negative 3 is 0, so that's not even a part of the derivative anymore. And then the derivative of x to the negative first is negative x to the negative second. So we can write that as 2 minus 1 over x squared. Manipulate, manipulate, manipulate. Last two. C. Okay, they give you a function. Y equals 3 times 5 minus x quantity squared. Find y prime. So again, we don't have this set up in a way that we can use our power rule, if you will. I want to manipulate this. I want to go ahead and square 5 minus x. So if we square 5 minus x, I like to use the shortcut. Square the first term. Take the product and double it. Square negative x, so positive x squared. Then distribute the 3. I'm going to put this in standard form. So I'm going to write 3x squared. You don't have to do this. I just like it in standard form. And then minus 30x. And then plus 75. This is y right here. This is the same as the y function. Now we can find y prime. Just differentiate every term. So we're going to get 6x minus 30. Manipulate, manipulate, manipulate. All right, the last question. Where does y equal x squared plus x have horizontal tangent or tangents? When it says where, they're asking for the x value, if you will. But understand the question. the question is really saying, I'm going to star this, I shouldn't say this, but here's how we can enter the problem. What is the slope of a horizontal tangent line? What is the slope of a horizontal tangent line? That's how we start. If we're trying to figure out where does this function have a horizontal tangent, let's think about what the slope of a horizontal tangent is. And hopefully you know that's 0, okay? So we're trying to figure out where does the derivative of this function equal 0. That's what we're after. Where does the derivative of this function, where does the slope of this function equal 0? So we're going to find y prime and set it equal to 0. That's the goal. Find the derivative, figure out where the derivative equals 0. That is where it's going to have horizontal tangent lines. Okay, so the derivative is going to be 2x plus 1. There's a 1 in front of the x. And we're trying to figure out where does this equal 0. So put 0 in for the slope and solve. Subtract 1, divide by 2. So x equals negative 1/2. This is where this function has a horizontal tangent, right there, at x equals negative 1/2. If the question did say at what ordered pair or at what point does it have a horizontal tangent, we could find that. This essentially answers the question of where. But just for fun, because this is fun, let's find the point where this function has a horizontal tangent. So anytime you want to find the y value of a function, add an x value. Plug this into the actual function, okay? So y equals negative 1/2 squared minus 1/2. So this is going to be positive 1/4 minus 1/2. Get common denominators, and you get negative 1/4. So if the question did say at what ordered pair, at what point does this function have a horizontal tangent, it would be at the point negative 1/2, negative 1/4. But that would suffice. All right, best of luck. If you have questions, don't hesitate to shoot me a Canvas message or email me. Best of luck. Peace.